Right. So this is week 5 of HIT137. So before I start with this class, couple of announcements. Next week is actually a semester break, so there is no class for us next week. Happy, right? Very happy. So after week 5, again, after next week we'll start again. Second thing is that I hope every one of you have already got your marks for your assignment 1. Your assignment 2 will be uploaded today itself, so I'll discuss a bit about your assessment 2 as well in the class. Guys, can I get your attention, please? Okay, it's important. And then after that, today will be pretty much the last week for us to work with procedural concepts and syntax. After next week, after this week, from week 6 onwards, we'll start working with application development. Okay, so that is important. So this is actually the final week for us to work with all codes and stuff. So I'll do a bit of revision as well this week, and that's all. And thank you very much to all of you who have submitted your assessments. Okay, there are only a couple of people who haven't, so I would like to request them if they can do it. If there's any problem, please ask us. It's important. And you already know that you have a couple of tutors who will be there always to help you as well. So please keep your track uh, good and healthy as well. Now, before I start the class, I would like to ask you again one more question. So, till week 4, have you understood so far what we have studied? Is it clear to all of you? Yes, sir. Very good. How about online students? Is it clear to all of you as well? How much you have studied till week 4? Is that clear? Okay, very good. Then let's start today's class and then let's finish it. Then after that, we have a number of things to announce as well. Okay, so what we're doing in this week, again, we'll be continuing with our functions. So remember that I already told you in the last week that a function is a very, very effective way of solving, of dividing a problem into subproblem, so that you can critically analyze, you can critically, make the whole problem into subproblems, and then you can manage them in a very fine way. So that is the importance of functions. And I already showed you in the last week that there are defined functions, there are predefined functions that you can use, and also you can use some built-in functions, right? I mean, so there are some built-in functions, and also you can use some functions that can be defined by yourself. So you can also define a functions. So there are a number of ways you can define functions. So ultimately, when you'll see in your assignment, in your exams and everything, you'll be exposed to either use some built-in functions or you have to define your own functions. So you know both of them actually how to do it. So today we'd like to continue more about that, but it's a bit of an advanced sort of functions we'd like to do it, and I'll recap what we have done till week 4 after today's lecture. So you know that actually a function is a sort of an abstraction, so it actually minimizes the complexity that you don't need to see. For example, if I say print or input or length, I mean, they have got series of tasks that should be done behind the code itself, which you can see, right? A function is something like that. It actually gives you a sort of abstraction of what you're doing, but at the back, you have a series of code that is there to run that function, right? So that is actually how this function works. So if you see, just to wrap up again what we have done in the last week, if you just see this one, we have defined a function called def using a keyword def, right? So that's your defined function. My function name is called sum, and it has got two parameters. One is lower, and another one is upper. Okay, and then we finish with a colon. Clear, guys? Is that clear, right? We have done that thing already. Now, once I get into the function, I have defined a variable called result equals to 0, and then I'm using a while loop to check as long as lower is less or equal to upper, this is true. And once the lower exceeds the upper value, then the condition will be false and the while loop breaks. Yes or no? Good. So what they're doing is they're doing result equals to result plus lower, right? So they're adding up the lower with the result value, and they are incrementing the value of lower by 1. So ultimately, and then once they finish it, once the whole loop finishes, then the function returns result. So you know that the function can return some value, which is a result. It may not return anything as well. But over here, our aim was to add up numbers between lower to upper, and then return the addition of that numbers. That is actually the main function over here. If you see, so for example, as you can sum 1 and 4. So I have called the function by the function name sum, and I got two parameters 1 and 4. So my lower is 1, my upper is 4. Okay, initially my result is 0. As long as lower is equal to upper, which is true, result equals to result plus lower, which is 0 plus initially 0 and lower is 1, so it's now 1. Next time lower will be 2, so 1 plus 2. Next time lower will be 3, so 1 plus 3. Next time lower will be 4, 1 plus 4. In that way it is adding up, right? Isn't that so? It's a straightforward. So we have done that thing already. Now if you want me to again divide that thing into small things, that means a serious issue you have. It's a very basic thing that we have done already. Ultimately, what it is doing, it is just adding up all the numbers between lower to upper. And once the lower gets above the upper, the whole thing terminates and it returns the result. So anything between 1 to 4, the addition of 1 to 4 is actually 10. 1 plus 2 plus 3 plus 4 is actually 10. Yes or no? So this is actually a simple function that we have defined, and this function is allowing me to add the number between a range. And the range has been defined from lower to upper. Clear, guys? Understood? Yes, sir. Very good. Then same goes with sum with 1500. So same thing, we have added all the numbers together and we got the result, and we put the result over here as 3825. So you can practice this thing at home. It's easy for you to continue. Now, so that was pretty much a defined function that we have already defined. We have built our own function by ourselves. Now we can also do a couple of things over here. So these are called some predefined function like apps. What is apps? It's an absolute, right? So any negative value will be converted into a positive value. So they will discard all the negative thing. So if I say 10 minus n can be anything. So if I say 10 minus 15, it will be, what is the result? What is the result? 5, not minus 5, yes? Absolute means what? You take the positive value of that particular value actually. So it's actually plus 5. Similarly, maximum, max is a function that defines, that actually is used to find the maximum between two numbers, n1 and 2. Similarly, input is another function that allows you to enter a number from your keyboard using a keyboard, right? So these are all built-in functions. And as I told you that as a part of your assignment, your exams, it's an open book. You can use any functions as long as you understand them. Don't copy and paste. It doesn't work in that way, okay? So as long as you understand them, you can use any functions. We don't have any problem. But try to keep yourself in a way so that whatever you learn in the class, try to use that one. Okay? If I suspect any function that you have used, you don't have any idea, I'll call you into my office. That is the important thing. We'll keep track of all those type of things. So it is very important to understand the functions that you're using. You have already learned that in the class. Anyway, so these are some of the defined functions already, built-in functions that you have already used it. Now, these are things we have already done in the previous class as well. Now, let's continue further. Couple of more: absolute value, maximum, minimum, rounding. So these are all, by the name itself, you can understand what this function is doing. Either it is taking the absolute value, it is taking the maximum value of the two numbers, it is giving us the minimum value of the two numbers, or it is rounding up the number. Suppose if it is 10.67, it will put as an 11, right? That is a rounding of that particular number. Anyway, these are all built-in functions that we know. Now, there's another function which I'd like to discuss in the PDF code that is called a recursive function. It's a very, very effective function in a sense that the definition of a recursive function is a function who has the ability to call itself is called recursive function. So I'm a function, I'm calling myself again and again. That is called a recursive function. So it's a sort of a looping. So same function, suppose named sum is calling itself again and again for a number of times. So if you see, this is actually called running a function for a loop, in a loop actually. So a recursive function is a very effective function. In that way, you can minimize the number of functions that you're using, and also you can make it very effective as well because it can call its function again and again, and it can keep track of the whole function operation. But the complexity of this function is that people always get afraid of this recursive function because those who work with pointers, those who work with, basic C programming as well before, they'll understand that it works with memory locations, changing the memory value, pushing the memory value, all sort of things comes into play. So this recursive function is a bit complicated in that way, but I will try to make you understand how this recursive function works, okay? And this is actually a very, very, very important function. Very simple. Same function calling itself, and then they do the operation. The only thing that you have to understand is that in this design, you should have a terminating condition. For example, while loop also has a terminating condition. For loop has also need to be terminated. Similarly, a recursive function that is calling itself again and again should be terminated as well somehow. So there should be some terminating condition that actually allows the function to terminate and exit from the program itself. Clear, guys? So I'll explain you, actually I'll show you how a recursive function looks like, but for that let us go to the PDF code and then we'll see how this particular recursive function looks like. So this is the pretty much the whole till week 5 whatever we're going to study. That's enough for us to finish our assessment 2. Our assessment 2 contains all the information that can go from week 1 to week 5. Let's go to the PDF code, then we'll understand what is there. Okay, guys, let me explain a couple of coding over here, and in that way we'll see how it goes. So this is the first code that I'm going to use, which is called, the program name is lower upper.py file. You know that actually what's py file. You already remember about the main function. When actually you have multiple functions, it is always good to use the main function. Even if you have also only one function also main, try to use the main function. That is a good convention of writing a function. In that way, what happened? The Python interpreter can understand this is my starting point. Okay. Suppose you have got 5 functions, you don't know actually which function to start with, and that's why main function is actually the function that tells us that is the starting point of my program. So once it calls the main function, it goes to the main, so which is defined. I have already main. As you can see in this function, again there is no parameter, so it's actually free. So there's no parameter over here. We're just defining the function. I have defined 2 variables, lower and upper. Lower variable, what it is doing? It is inputting a lower value, input that thing, and as we know that this number is actually a character, it is converted to integer. Clear, guys? Right. Similarly, upper also, take the upper, then convert the thing integer. So there is enter lower and enter upper. So if I see, it is 5 and 10. So the lower value was 5 and the upper value is 10. Okay. Then after that, what I am saying, I'm calling a function called display range. So this is my function name with the parameter lower and upper, which is 5 and 10. So I'm calling the function display range with 2 values, parameters, one is 5 and one is 10. In that case, lower is 5 and upper is 10. Now, so this will call the function this one. So here it is 5, here it is 10. Okay. We have used a while loop. As long as lower is less than equal to upper, that means as long as lower is less than equal to upper, print lower. So that is 5. Then lower equals to lower plus 1, which is 6. Again, print 6, 7, 8, 9, 10. So 10 is less than equal to 10. That's perfect. And then once the lower goes to 11, this is false, then it will terminate, right? So at the end, we get this particular output. Isn't that very easy? So this what we have done actually over here. We have only printed a number from lower to upper using a function. Okay, guys, understood? Good, very good. Next, over here, this is something where actually another one. I use a function called main function. Guys, please don't talk because it really interrupts me, please. Okay, just give me some time. Once I finish, then you can start talking. Huh? A main function. So this is the main function. Once I call the main function, it goes to the define main function. Again, it is looking for a variable lower. It takes an integer lower, convert into integer number, upper integer number. So suppose 5 and 10 again I have given. I've called lower and upper. Okay. Once I've called lower and upper over here, so what is happening? So this particular function calling display range with lower and upper is calling the function as 5 and 10. If lower is less than equal to upper, yes, lower is less than equal to upper. That's true. Print lower, so print will be 5. Now over here, I didn't do anything like I didn't in the previous one. What I have done, I've incremented the lower by lower plus 1. But over here, I haven't done anything like that. What I have done, I just called the function again. So you just see this function is calling itself again. Yes or no? So this function is calling itself again. So once I'm calling it, this time I have changed this thing from 5 to 6 and 10. So this will go over here again, 6 and 10. Yes, lower is less than upper, so it will print 6. Again, display range lower plus 1, so it will be now 7. 7 and 10, 7, yes, true, 7. Then it will change to 8, 8 and 10. So every time what I'm doing, I'm calling the same function, and what it is doing, whenever I'm calling the function, I'm just incrementing the value of lower, and I'm checking the value of lower with the upper. As long as lower is less than upper, I'm printing the value of lower. So this is one small classic example of using a recursive function. I mean, this is one way you have done it. This is another way you have done that as well. Both of them are very easy to be understood, but ultimately the importance of recursive function is that you can call your function again and again, and you can reduce the number of functions if you would like to. And you will see that recursive function will come when actually you'll be starting with your software development as well. They'll be able to see there are a lot of codes based on recursive function as well. But anyway, so this is the gist of this particular thing, that what actually the recursive function looks like. Now, this is the most important bit, and I really need your full attention in order to understand this recursive function. Now, especially some people don't think that it is important to explain that details, but I think it is important because in that way you can understand how this recursive function works. And if you don't understand, please ask me again. But let's solve this problem because it's a bit complicated problem as well, and then we'd like to solve this problem in a very nice and easy way. And for me, believe me, so I mean, explaining a complex problem is not that hard actually. I mean, if you are with me. But let's start. Okay. This is the main function. So I'm going to explain you how the recursive function works. So main function calls the defined main function. It takes a lower value as enter lower and the upper value as input as integer. And then, so think in this way, that lower value was actually for me as 2 and upper value is 5. So I put the thing in the table as 2 and 5 over here. Just I put those things in a table to make you understand what actually all these things are. So let me put it as lower and this is upper. Clear, guys? Up to this 2 and 5. Then I'm calling sum lower comma upper. So I'm calling a function called sum, right? So this is my sum function. My lower is how much? 2 and my upper is 5. Okay. Then I'm saying print lower comma upper. So that means if you see the console, because I didn't print the output, but if you see the console, it will print what? 2 and 5. Yes or no? Yes. That's clear. Up till this is clear. Okay. Now if lower is greater than upper, is lower greater than upper? No. So that's what is output? False. Is that correct? So if lower is greater than upper, then it will print exit, otherwise I will return 0. But it is not greater than upper. So what it will do? It will go to the else condition. Yes or no? Yes. Okay. In the else condition, what they have done, they said result equals to lower, which is result equals to lower, which is 2. Lower is 2 plus sum lower plus 1 comma upper. So I'm going to again call the same function with 1 increment of lower. So my sum is now what? 3 and 5. Yes or no? Now when I'm going to call that thing, automatically my interpretation, whatever, it will jump from here to here again. Yes or no? Yes. But once it jumps, so the way actually the Python works, or the way actually the compiler works, before it jumps to the next execution, it saves all the thing that was supposed to be executed, but it couldn't execute that thing. So that's why what they have done, they have saved all this thing in the memory. So all the instructions after that particular function call should be saved because they're not executed. Have they been executed? No, because it has already jumped to the main sum function. Yes or no? So that means because it has jumped to the main sum function again, so all the operations under the sum function should be stored in the memory. Clear, guys? Okay, let's continue the next one. Now my sum lower is now how much? Lower is 3 and upper is 5. Yes or no? So my lower is 3 and upper is 5. Okay. Then I'm saying print lower and upper. So I'm going to print lower and upper 3 and 5. Yes or no? Good. Then I'm saying if lower is greater than upper. Is lower greater than upper? No. So it's false. So this will not work, right? So this particular if function will not work. So it will jump to where? Else. Once it goes to else, it is saying result equals to lower. My lower was 3 plus sum lower plus 1, which is 4 and 5, right? Lower is actually 3 plus 1, 4, 4 and 5. So again, I am calling again the same sum function. Once I have called that thing, automatically anything that is below that should be stored in the memory. Clear? Again, it has jumped to the main sum function. Clear, guys? So far, are you clear what I have said? Understood? How about you guys? So this is simple. I'm just saving that thing. I'm going. Let's continue further one more time. So now my sum is 4 and 5. Yes or no? My lower is 4 and my sum is 5. Print lower comma upper. So 4 and 5 I have printed. Then I'm saying if lower, so this is 4 and this is 5. If lower is greater than upper, no, lower is not greater than upper, so which is 4 is not greater than 5, which is false. So it will not work. So this particular statement will not work. So it will go to the else again. In the else function, it will go to the result. Okay, result equals to lower, which is 4, plus sum, lower plus 1, which is 4 plus 1, which is 5, 5 and 5. Yes or no? So once I've called this thing, again it will jump over here. Again, I'm calling the same function. So this is called a recursive function. I'm calling it again and again and again and again. But the beauty of what I really wanted to show you over here is that whenever it jumps, it saves all the other instruction that was there in that else block, because that need to be executed once it comes back. So recursive function is something like it starts from top to bottom approach, and then once it solves, then again it goes to bottom to top approach. In that way, it starts solving. So now again, this print result and return results are already been stored in the memory. Clear, guys? Okay. Now it moved to now is my lower is 5 and my upper is 5. Yes or no? So my lower is 5 and upper is 5. So print lower and upper, which is 5 and 5. That's perfect. If lower is greater than upper, is it true or false? Lower is not greater than upper, right? Lower is equal to upper. That's true, but lower is not greater than upper. So it's still a false. So if it is false, what it is saying, it will not work in this one. Go to the else function. Again, result equals to lower, which is 5, plus sum lower plus 1, which is 6 and 5. So lower plus 1 is 6 and upper is 5. And it will jump again to the main lower sum function. Yes or no? And once it does it, it already stores all the results in the memory itself. Done? Good. Now I told you that in a recursive function, it is always important to have some terminating conditions. If it doesn't terminate, it will keep on in the infinite loop. It will keep on calling. So there should be some stop for that one. Okay. Now, again, it goes with lower and upper. So it is now 6 and 5. Yes or no? So my lower is 6 and my upper is 5. So print lower and upper, which is 6 and 5. Clear, guys, up till this? If lower is greater than upper, yes, lower is greater than upper. That's true. Yes or no? Yes. That's true. If it is true, then what will happen? It will print. So it will execute these values. Yes or no? It will execute all the statements under the if command, not in the else command anymore. Yes or no? Okay. Once it executes, automatically, if the first thing it will do, what it will do, it will print exit. So that means that the first thing it will be printing exit, and then it will return a value called 0. Now this is actually called how it is building. So initially started pushing every data in the memory. Okay. Now you have to extract every data in the memory to come to the bottom part. That's how it works. Now you see this particular 0 that is returning. This particular 0 that is returning from this function was initially called by 6 and 5, right? Because they actually call this function, this 6 and 5 actually call this function this one. Yes or no? And when it is going to return that 0, this 0 will go to which function? 6 and 5? Because 6 and 5 actually was the last one that asks for the sum function. And when the sum function is terminating, it says, okay, I don't have any more operation to do. It is true, lower is greater than 2, I'm going to return 0. So this 0 actually was called by whom? The previous sum function. Yes or no? So that means this 6 and 5 actually was calling that particular function, and they said return 0. So automatically what is happening? So when I'm saying return 0, so once they said return 0, it will go as 0 for this particular whole sum. So I'm saying the sum of 6 and 5 over here as a function, the return value is 0. So if I see, This is initially it was like that 5 plus sum 6 5. So because it has returned 0, so it will be 0, which is 5 plus 0, which is this one. And then, so what is the result now? 5 plus 0 is what? 5. That is the result. Okay. And then I'm saying, now once it is done, so all the operation under that particular sum function need to be solved, because this has been pushed already in the memory. So that need to be executed. So what it is saying? It is saying print result, which is 5. Yes or no? It is going to print result. And it is also returning that result. Yes or no? So when I'm returning that result, this result was called by whom? The previous function, previous sum function. Yes or no? So this particular result was been called by the previous sum function. So my previous sum function was 5 and 5. Now the result that was returned was actually 5. So this result is 4 plus 5, which is 9. So yes, so it is actually returning the previous sum function result, which is 5. So which is now 4 plus 5, which is 9. Again, all the things under that function need to be executed. First of all, print result, which is 9. Clear? And then return result. So what I'm returning over here? What is the value I'm returning? What is the value I'm returning over here? 9? Yes or no? Because I'm printing the result, which is 9, and I'm also returning the value called 9. Now, when I'm returning that value, this particular value was called by whom? Called by the previous sum function, because it was asking for that one as well. So this result value will come to where? To this particular previous sum function, which is 4 and 5. So I know that the sum of 4 and 5 was actually 9. Okay? And my result was 3 plus 9, which is 12. So I'll print that result 12. Again, I will return that result. And that result will be called by the previous sum function. So now this 12 is there, plus initially 2 was there. 12 plus 12 is 14, and I'm going to print the result as 14 as well, and I'm going to return that result. And that's pretty much all of the main function. Now, although it looks a bit complicated, but the beauty of this thing is that once you build up all the stack, and then once you come down from the stack, it is just the results are pushing down from top to bottom in this way. Now you have to have your very nice sharp thinking how it works. I will explain one more time. Okay, if you don't understand, please raise your hand, ask me why you didn't understand. But let us clear this concept very easy way. It's not that hard actually for us to clear that concept. Let me, I'm not going to do the pushing one. I'm going to do the popping one. Okay, because you understood the push one easily. Okay. Just give me a second. I'll make it look nice first. Let me clear these things. Okay. I mean, I will start with over here that I'll start with over here when my lower was 6 and my upper was 5. Okay. So I know up till that I have pushed everything properly in the memory, right? So I have already pushed everything in the memory in this way. 2 5 false. I get that. Look, whenever I'm calling the next function 4 and 5, then 5 and 5, then 6 and 5. So similarly, when it will come down, it will pass the result from 6 and 5 to 5 and 5, 5 and 5 to 4 and 5, 4 and 5 to 3 and 5. This is actually how it will work. Okay. Now, what I am saying, 6 is greater than 5, which is true. That is true. So I'm saying print exit. I'm going to print the exit, and I'm going to return the value 0. Now you have to understand that who called this function? The previous function called this function, yes or no? So what was my previous function? 6 and 5, yes or no? So that means my previous function sum 6 comma 5 was calling the function of this one, the last one, right? So now when I'm going to return that 0, so who is going to hold that value? My previous function. So my previous function was 6 and 5, so it will be replaced by 0. And all the other things will be same because everything's been stored in the memory. I know my initial result was 5. 5 plus 0 is now 5. Yes or no? So I'm saying print that result, which is 5, return that result, which is also 5. Okay, so I'm going to print that result 5, and I'm going to return the result also 5. Clear, guys? Now you tell me, when I'm going to return the result, who called this function? It's a previous function who has called this function. So 5 and 5 actually has called 6 and 5. Yes or no? Because 5 and 5 actually was calling me the previous function of that one. So when I'm going to return that 5, that result, who will hold that result? The previous functions of that one, who called that one. So this is actually sum of 5 and 5. So sum and 5 and 5 is actually 5. That has been already given by the previous function. So I'm saying 5 plus 4 is now 9. Now, you know that this function was called by this 4 and 5, right? So 4 and 5 was calling 5 and 5, yes or no? 4 and 5 was calling 5 and 5. So when 5 and 5 returns the result, what the result will come? It will come to 4 and 5. So that's why it's 4 and 5, which is 9. Now, 3 and 5 is calling whom? 4 and 5. So if 4 and 5 is returning result, which is 12, that 12 will come to sum 3 and 5. And then that's the final result over here. So the way actually it works is that you have to understand that when I'm going to the first return, if you can catch the first return, all the thing will slowly fall down in the same process. It's called a waterfall method. It is going to follow the same strategy, right? So if you see, if I can hold the first value, which is 0, now this 0 was called by, this return was called by, this function was called by whom? By this function. So I get the 0 over here. Now, whatever results I get from here, once they return the result, this result will be called by whom? By this block of functions. And whatever result I got from here, this result will be called by whom? This particular block of functions. So initially I'm pushing everything, and then after that, once I got the return exit, I'm popping everything one at a time based on what they have called. Understood? Yes, clear, guys? Yes. How about you guys? Clear? Yes, are you sure? Yes. Let me see online students, my lord. Online students? Is that clear? Okay. Now the thing is that if for any reason, if you don't understand that, again I will repeat it again in the coming weeks. But this is a very basic thing. Just follow the table, okay, and try to understand where the return condition is. And once you pick the return condition, you can easily go back and you can start populating all the results. Okay, so this is actually called a clear way of recursive function. Now I could have showed you that thing from the memory point of view, but I thought it's better to do it in a tabular point of view. How actually the results comes from one to another. Finally, what I'm going to say that always keep in mind that when I create this type of block, okay, this block will never execute it. This block will never execute if it doesn't get the results of its next block. Okay, and then similarly this block will never execute if it doesn't get the result of the previous block. In that way, all the results is pushed down, and then you get the final result. And this is actually called a classic example of a recursive function. So in your exam, if I give you a table like this, and I'll tell you fill out the table, so you have to know actually how to fill out the table. If you can keep track of the recursive function, as you know that this function is calling the previous function, previous one is calling the previous function. As you can build up this strategy, and once you start popping up, if you can build up that strategy, life is very easy because everything remains same. Everything remains same. Only the value that is changing is this one. So sum 6.5 is calling the previous function, sum 5.5 is calling 6.5, sum 4.5 is calling 5.5, sum 3.5 is calling 4.5 in that way. So whenever they push the result, it goes from top to bottom. In that way, the whole function comes to an end. Understood? Good. Let me have another recording and then we'll continue further.